to talk about serverless, why you should use serverless in your APIs, and specifically we're going to look at DOWN as a platform. A bit about myself. So I'm Jonathan, as Graham said, developer working at Malton in Newcastle. So we are a headless commerce platform. We have APIs for commerce. It's in Boston and Newcastle. I work on our dashboard team and contribute to API tooling and open source stuff like our SDKs. Also, Corn First Means Everything. It's a company that we run functional fitness competitions. It doesn't seem relevant, but I built an open source GraphQL API that we handle kind of athlete payments, registration, workout scores, comp leaderboards and stuff. So if anyone's into GraphQL, can chat about that at the pub afterwards. We'll go back to serverless for now. So what is serverless? So yeah, service architecture really, also known as service computing or function as a service. It's a software design pattern, and that is where you defer your applications to hosts, third-party hosts, to abstract away that managing of servers, managing of infrastructure. Applications are generally broken down into functions, or lambdas as they're commonly known, and those functions are invoked and scaled individually. So why serverless? So obviously right now a lot of people are using kind of monolithic architecture in their APIs and the servers. So what benefits does going serverless bring to your stack? No servers, kind of. The term service is somewhat of a misnomer. They are still servers, computing your code, running your code. The benefit and the reference that there is no servers, that configuration, as I said before, is abstracted away to other platforms. People like Amazon, people like Google, Zeit, they are taking care of the servers that actually power your code. So it's important that that is abstracted away, and you can actually then focus on the performance and execution of your application code. Probably everyone's face now when it's like serverless, there's still actually servers involved. It's like what? So kind of like that slide, no one else does. Yeah, cost reductions. Essentially, you're only actually paying for resources that you're utilising. So the premise of serverless is based entirely on execution of code. You invoke a function, it runs, it shuts down. So you only actually build for that runtime, that execution time of the function. And that is, completely juxtaposed to something like Heroku or things like traditional things like that, Amazon EC2, where you're paying for that complete uptime of that instance. So there's significant cost reductions there that can be taken advantage of. On the flip side of that as well, these functions will scale infinitely without you having to concern yourself with ramping up your servers, etc., etc. So the serverless functions are stateless in nature. Majority of the time they're invoked by events, mostly HTTP requests. So you can run as many or as few as you need. So if your applications run viral, it's not a problem. The serverless architecture, the functions will scale infinitely alongside that. And all of these kind of problems allow you to then focus on your actual application. You don't need to be worried about the configuration of your server. Like I said, scaling your server. Who actually wants to do that? We should leave that to people who are actually really good at that, Amazon, Google, etc. So you can then focus on making your application as performant as possible. Serverless computing has a long storied history. It's really become kind of a strong topic within developer communities within the past 4 to 5 years, I would say. And it's already used heavily around us. IoT devices, Alexa, majority of those things are serverless functions. Third-party integrations are usually serverless functions. You want to listen to a webhook, fire off an event, trigger an email, something like that. That would generally be a serverless function. Those are just a couple of examples of how it's used, and obviously APIs are another use case, and we'll get to that. At Molten, we're using serverless functions, not only in the front end, but our back end. We do caching validation with serverless functions, so we have caching from the API. If somebody wants to update a product, we need to invalidate that cache. So we have internal events that would fire off a serverless function to invalidate that cache with Fastly. We also use it with our billing system, so we defer the majority of our billing to Stripe. But if a customer has updated their plan, we need to notify Stripe of that, so we do that with serverless functions and so on. And a lot of our customers as well, using Molten, our event service, to kind of polyfill holes in our service, not holes, intentional holes, shall I say. Things like transactional emails. People will use our event service to fire transactional emails with Postmark, SMS with Twilio, things like that. So those are all service functions. And Jamie's done a great job with the examples of those that are on GitHub. So yeah, as I said, a lot of people, their approach to kind of APIs and server-side code is a kind of monolithic approach. If you think of Node, people use kind of Happy, Express Core, that kind of stuff. And they rule the roost. They are popular for a reason. They're very easy to get started with. They have a lot of functionality out of the box that provides people to get up and run really quick. Things like routing, middleware, etc., etc. So more often than not, that complexity and that functionality that those frameworks bring is actually bloated, and it's pretty much overkill in most cases for some projects. And that functionality can be easily achieved as well with a serverless approach. Yeah, so this is Marie Kondo. Don't know if anyone watched the Netflix show, but it's pretty awesome. So what she kind of preaches is simplicity and kind of decluttering, and she thinks that's vital to like a happy home. I think that principle is kind of applies to us, the kind of server architecture. I think if you can have a really kind of clean, decluttered server or API, then you're going to have a happy API, and you'll be happy as well. I mean, come on, this ties there. So kind of what benefits does going serverless on the API, what does that bring? First one is separation of concerns. So each function in your API, it would be isolated. It handles its own responsibilities. They have a sole responsibility. They run in isolation. They start, they execute, and they shut down. So we might have a route that is handling authentication, and we need a dependency from Passport.js. This separation allows us to kind of specify that. So we're making our bundles as lightweight as possible. And also helps as well with surfacing errors and debugging code if we are only actually including dependencies or modules that we need for our functions to execute. Stability. In a monolithic node application, there's a single point failure. If your Express app errors, then because of a particular line of code in one controller or one route, then the whole thing's going to error. That's not good. We want the rest of the application to be available to our users. So with the serverless approach and the isolated function approach, each function runs in isolation, as I just said, and that allows things to error gracefully in a way. So that would mean somebody's hitting endpoint A and it's erroring, that's fine. Endpoint B is still accessible to our users. That's probably one of the strongest benefits of the serverless architecture approach. Shared resources. So as I mentioned, things like Express, and they have middleware that kind of perform common functions for each route. That's useful. But we can kind of work around that with shared resources, local dependencies in your application. So you comment to abstract any logic or state into libraries. You can pass that around your application into your functions. This might be something like a database connection, middleware, or connecting to external services, something like if you're handling payments, perhaps Stripe. Yeah, so service approach as well is language agnostic, and by that I mean if you're creating an Express application, then you're going to have to write JavaScript or Node.js. In a serverless architecture, whether using AWS API Gateway or now, your functions can be written whatever language you want. You can have 10 Node functions, some Go function, PHP, whatever you want. You're able to use the best language for that purpose, for that job. And they compose together to make the API. So yeah, hands up who's heard of Zeit? So Zeit, they've been around since 2015 now. They're kind of at the forefront of the serverless computing movement in my eyes. They're famous for Next.js. People heard of Next.js, server-side rendering React framework. Micro as well, which is kind of a really small asynchronous node framework. It's good alternative and actually pairs really nicely with server stuff. And of course Now, which is their cloud platform. So Zeit are a company that I really like and I really strive to use in most projects, because they take the pain away that sometimes is associated with AWS, getting up and running and stuff. So this is their kind of company mission. And this was kind of echoed in their kind of actions last year in November 2018 when they launched version 2 of Now. So they kind of completely rebuilt their Now platform, essentially making it a kind of a build compiler. So you compile it, kind of pass it source code in any language, and it'll actually compile all that down to a Lambda. So their approach now for their platform is kind of completely Lambda based. Everything's serverless. Also included in that release was kind of this monolithic support. So you can have this single GitHub or GitLab repository in your version control, and you can have a single configuration, and then you can actually kind of create these builds from individual functions or handlers. So that was really powerful, and that kind of helps people compose and construct these serverless APIs. And I think the combination of those two really made kind of serverless APIs a possibility today, really easily. Who's used Zeit now? Okay, everyone from Malton. Yeah, so I think Zeit now, what really, to me, is kind of best thing about their philosophy and approach to everything is the developer experience. So they've got like immutable deployments, auto aliasing, global CDN. It's ridiculously easy to deploy there. You just kind of, if you've got the CLI tool installed, you just kind of have your config set up, have your functions, hit Now in the CLI. You've got an immutable deployment there within a few minutes, really. These have kind of made, all these things have made it getting started with Now the gold standard of the platform. So as I mentioned as well before, the serverless API can be language agnostic. It's not tied to a specific language. and now when they released now version 2, they came up with all these builders that they call them. And what that does is you pass it your source code, whether that be Go, PHP, Node, etc. And they'll use your builders, you specify the builder for the language, and it kind of compiles the Lambda function. So they have a large selection of builders. We've got Node.js, Go, PHP, Python, recently released Rust, static assets as well. So if you're using a Gatsby site, you can kind of deploy a static website there. Yeah, so the builders really are at the core of everything. You compose the builders in your configuration to put those APIs together. So whether you're using Node, Go, PHP, etc. This is an example, pretty basic example of a function. This is something we're using at Morton to reset passwords. So basic async function takes a request, sends a response. You'll notice we're using local dependencies here. So we're requiring a Morton client. So that's actually specified the root of the repository. We can pass that around to the functions that need it. The functions that don't need it, then we don't have to include it. So they get a much smaller bundle size. So that's a kind of really basic example of now's approach to a node function. It's using micro as well, as I said before. That's now's asynchronous library. Config. It's a JSON file in the root of your project. This is read during deployment. What you kind of specify here would be environment variables, so anything from secret keys, etc. Configuring your builds, so you pass it a source path of the code. You tell it which build to use, whether that be Node, etc. And then now reads that, creates the lambdas at build time. And also, you have to set up the routing. So it's kind of like API gateway, where you are actually saying, hit this URL. This is going to route to this lambda. So all of that is specified in one JSON file, which to me is like, it seems scary initially because there's a lot of power and configuration there. But the beauty of it is in the simplicity, and it's just a JSON object. Once you get familiar with the syntax and how you actually kind of structure that stuff, then it's really powerful. So yeah, that's actually a config for the tool that we use internally. So as you can see, we specified an alias. We've got build environment variables, so they are kind of reading from now secrets, encrypted environment variables in the now platform. Specify an array of builds, so we're passing in the actual root of the source handler and which builder to use. As you can see, we're using now here, Node, sorry, in every instance. We need to root as well, so we're just saying kind of each handler we have, we want to defer that URL to the relevant handler. So it's pretty straightforward. You can do some stuff with the roots now, so you can specify HTTP methods, things like that, redirects, that kind of stuff, so it's pretty powerful. Deployment, deploy direct from the CLI. So once you've kind of fully configured your project, you can easily deploy in the now CLI tool with just that command now. So that will actually kind of check for the config file. If there's no config file, then obviously it'll error, but it'll read from the config file and build what you've told it to build. What's even better, in my opinion, is kind of the integration with version control. So using GitHub, or as of a few days ago, GitLab, they support GitLab now. Every commit to version control is an immutable deployment. So you can commit to your pull request, and you get a new instance of that commit to test whatever you want. Excuse me. So that will trigger commits, and then what will happen is as well, once that kind of pull request is ready to be reviewed or merge that into master, that then triggers a new build, which would then be aliased to kind of the production alias, which we specified in the previous config. So kind of getting zero downtime, CD, continuous deployment from like next to nothing really for free. So that's pretty awesome. And the CDN as well, like takes care of delivering that throughout the world. They've got they recently had launched a CDN Tokyo, so they've got like EU West, US East, US West. Where else? I think there's one in Argentina. Excuse me.
Elsewhere as well.
Yeah. So yeah, deployment is super simple. It's really easy to get up and running. It's kind of all I have.